Okay, so we are continuing with our schedule. Well, in this second part of the workshop, we'll have 3 presentations, basically describing the work in the mail project, and we'll have a roundtable at the end. So our next presenter is Professor Charalampos Georgiadis. He's assistant professor at the School of Civil Engineering, the Aristotle University of Thessaloniki, and he did the PhD in the Department of Spatial Information Sciences in the University of Maine, and well, he has been working in the project Mail in the tasks related to financial, social, and technical aspect of the sustainable development of marginal lands. So his presentation is about the identification and classification of marginal lands in Europe. So mainly technical and methodological. So Harry, you ready?
Yes, just let me share my screen. Okay, Luis, can you see it? Is everything okay?
Yes. It's okay.
Okay. Thank you, Luis, for the introduction. I'm part of the coordinating team. Aouf was responsible for the methodology development about the identification and classification of marginal lands in Europe. So, our overall approach to identifying marginal lands in Europe came from the fact that we need a common methodology across the whole European Union. The restrictions that we have to consider was that each region has its physical characteristics. So what we decided to do is to apply a two-step methodology. We start from the whole European Union and then we apply hard thresholds. What are hard thresholds in a bit? It's a concept of lands that they are surely not marginal. So we detect this and we start subtracting these areas from the European area. And we result with a classification of potentially marginal lands. And then we apply soft thresholds that have to do with the topography, the productivity, the sustainability, and the soil characteristics of the region. And after that, finally, the final step is the classification of marginal lands in the 3 different classes, which will be marginal lands with a high plantation suitability, marginal lands with low plantation suitability, and potentially unsuitable lands. So here we can see the hard threshold approach. So we begin using the European Union base map, and then we start to define the other land cover, which might be peat bogs and marshes, the forest area, the areas that are protected, the areas that have changed, the in previous areas, and we come up with the marginal land classification. And using this layer as input, we compute weights for different soft constraints, which might be terrain indicators, soil indicators, sustainability indicators, and productivity indicators, and we end up with a final classification of marginal lands. Here we can see the types of layers that we used. So basically, we used the definition of marginal land that was defined early in the project, and also we investigated and used all the datasets that were retrieved during the preparation stage, and we came up with using about 29 to 30 layers to do the final classification. So the hard layers basically are land cover layers, is the S2 GLC layer, the correlate cover and the correlate cover chains, the high HRL impervious and impervious chains, the global forest chains, national designated areas, and the Natura 2000 layer. For the terrain and soil, we use the European Union DEM and the European Soil Database. We used 5 different layers from the European Soil Database. For sustainability indicators, we used the soil pH, 3 layers from the WISE dataset, the Rusler 2015 dataset, the JRC Global Surface Water dataset, and 2 layers from the Terra Climate. And from productivity indicators, we use the soil organic matter, the soil biomass productivity of forest areas, the soil biomass productivity of grasslands and pastures, and the soil grids, which has a 250 meters resolution. So in order to define which indicators we are going to use and what will be the thresholds and the units, we did an extensive literature review. We identified the thresholds and the units, and based on the available data, the available free data, because the whole approach is based on data that can be downloaded by anyone and it's open and free, we came up with a design of the marginal land indicators for ML. So also we must note that the final map was created with a 10-meter spatial resolution using the ETRS-89 reference system and using the LAEA projection. So here we can see the workflow for the processing of the hard layers. So we use the SLGC and we mask some classes and we produce the other land cover. The same goes as a workflow for the forest area. So finally we come up with a mask for the forest area, for the protected areas, for the croplands and the change areas and the previous areas. And the combination of all these areas give us the areas that must be excluded from our soft indicators approach. With respect to the soft layers, we did a literature review to select the layers and to define the layer thresholds. We did a ranking of the above of the available indicators based on how much they are mentioned in literature. So if researchers use them and how they use them, we constructed a pairwise comparison matrix in order to identify the ranks. We normalized this, the pairwise comparison matrix, and then finally we assigned weights to each indicator. And after the definition of the weights, we fused the marginal land layer. So we had the soft overlay, which is an overlay and fusion of all the soft layers. We fused that with the hard layer, and finally we classified marginal lands in 3 classes. The marginal lands with a high plantation suitability, with low plantation suitability, and potentially unsuitable lands. Here we can see a classification based on the hard layer approach for the whole of Europe. And here we can see 3 different classification results using also the soft layer. So the one approach, the first method, basically divided the mean maximum range that we have for the total weighting of the soft indicators. We divided that by 3 and we created the 3 classes. The second approach is based on defining one class between 1 and 25th percentile, 25th and 75th percentile, and the rest as unsuitable lands. And the third option was using the 33rd and 66th percentile. In order to assess and evaluate our results, we did an accuracy assessment we used two methods. One was point-based and the other one was area-based. The accuracy assessment was under the supervision of UPV, which is the task leader for the respective tasks. So it was under the supervision of Professor Luis. And here we can see the results of marginal land in the four participating countries. We use, as I said, two methods, one based in points and one in areas. For the point-based method, we used the stratified random sampling. We computed the error matrices and finally we came up with the accuracy assessment results. Here we can see some example of the validation polygon. So for each country, we selected some areas that we have information about lands and if they are marginal or not. Here we can see some examples for Greece, Spain, Poland and Germany. And here we can see some statistics about the areas, the total areas that were used. For example, for Greece, we have approximately 15,000 hectares, which about 8,000 of them was classified by the expert as marginal lands, and 5,000 were classified as non-marginal lands. And here we can see the statistics for all the countries. And based on that, we did our assessment, and we can see that for Greece, the reference were 7,1987 hectares that were marginal land, while our algorithm, the marginal land, the hard threshold, only identified 5,646. So we can see that we have an underestimation in the case of Greece and Poland, while we have an overestimation from Spain and Germany. And also we can see in the results that we have a very large overestimation for Germany. And this is basically what we think is due to the fact that most of the areas that were given in the validation site was not marginal land. So we can see, for example, for Germany, while we have a total area of about 21,000 hectares, only 352 of them were marginal as ground truth. Also here I can show you the researchers that was involved. So for the development of the methodology for the identification of classification of marginal lands, the researchers that were seconded was Rodrigo Gomez, Natalia Verde, Maria Tasopoulou, Michael Krupinski, Eva Gromi, and Sebastian Alexandrovich and Jesus Toralba Perez. For the assessment, the accuracy assessment, it was Anastasios Tamnas, Abdulhazim Hassan, Georgios Panos, Zoe Toloudi, and to work under the supervision of Luis Ruiz, Juan Pedro Carbonelli, Jesus Toralba Perez, and Elke Krautsmar. So thank you for your attention, and I'm ready to take any questions.
Thank you, Harry, for the presentation. This technical presentation. So we have any particular question? I don't see anything. Oh yeah, we have a question from Vasily Kilapa. Is there map data at the level of regions in Greece?
In the level of regions?
Yeah, regional level, I imagine.
Let me see the chat so I can see the questions.
Yeah. The question is if there is any regional map in Greece, I imagine with higher resolution than the national one, or I don't think there is.
We haven't found any. I think that Labros that was working in the pilot case studies they have found some additional layers from for Greece, but I don't know which is their nature.
Yeah, at least in the framework of the project, we didn't develop any original map.
No. In the project, we just developed a map for the whole Europe, and only using European or global datasets. We didn't use any national datasets because that would have a problem in the methodology. We had to apply a different methodological approach for every country or every region. Our initial aim was to come up with a methodology that can be applied to the whole European region. So, but if there are any regional data that can be used, this can be enhance the identification and classification methodology afterwards.
Mm-hmm. And also just one question and for clarifying. So the soft approach that was applied in the project was mainly focused in forestry, in forest carbon sink perspective, right? Or, well, it's applicable in general way, but a little bit more focused in that way, right?
It was just to find what is marginal. So if the soil is not good, then we can have a marginal land. But you can adapt the weights to accommodate different type of plantation. But the general idea was to use it as carbon sink. So basically use it for reforestation or afforestation processes.
Mm-hmm. Just a clarification, because in the MAGIC project, they have an agricultural approach that is makes some difference sometimes in the factors used. Right?
Our focus was just to use it as carbon sink, and carbon sinks are usually forests.
Mm-hmm. Okay, thank you. Thank you very much for the presentation. So let's go to the next one. The next presenter is Michał Krupinski. He's received a bachelor and master degree in geodesy and cartography from the Military University of Technology in Warsaw. And well, he's a geospatial analyst in the Space Research Center of the Polish Academy of Science in Warsaw. He's a coordinator of this center in the MAIL project, and his presentation is about the MAIL map portal. He will introduce the MAIL map portal, online tools for marginal lands management and monitoring, a general description of that. So, Michał.
Thank you very much for introduction, Luis. I will share my screen. Can you see my presentation?
Yes, if I don't know if the microphone, you can put it closer or increase the volume a little bit.
Okay, I'm trying. How about now?
Now it's better. Thanks.
Great, thank you. So welcome everyone. I would like to give you the brief introduction to one of our products, the outcomes of MAIL project, which is the MAIL map portal. And first of all, I would like to thank to people who were directly coding and developing this tool, which are Marek, Jesus, Fernando, Pablo, Zoe, Yorgos, Janer, Lefteris, Francisco, and actually all the other MAIL second descent coordinators who were involved in this process, because this portal shows different solutions, different algorithms, different results and maps, which actually were developed by different work packages, different groups, and but these people listed here were specifically devoted into the development of this platform. And it also shows that actually all the partners of the consortium were strongly involved in preparation and development of our final portal. The main objectives behind the portals are firstly to present selected outcomes of the project, to provide user-friendly interface for our maps, results, and solutions, and to do it in the special domain, not just as the reports, deliverables, which it would be difficult to read because there are already hundreds of them. We decided to create a portal where all the results will be presented in nice and user-friendly way. And also very important objective is to enable users the analysis of CO2 sequestration potential of marginal lands. To do this, we decided to prepare the website, but actually the website, it's naturally the best way to present the results in the current way, but we decided to create the Geoportal, so the interactive maps and tools to analyze these maps, and we called it Mail Map Portal. In order to do it, we had few discussions. Actually, we were changing the ideas, and generally we were struggling before two options. Or we should create the basic version, simple map viewer, so the users, everyone can see the results, the maps for specific region or for the whole Europe. Or we should create kind of expert version of our portal where the user can play with parameters, can create his own analysis, he can modify the parameters, he can create his own version of our methodology. So in fact, it was a very hard choice because both solutions had pros and cons. And for example, what could happen if we give the total freedom to the user? If he selects the specific parameters, in, let's say, best scenario, he can create the whole map of Europe, and his result will be the whole land over Europe, and it will be his potential marginal lands. In the worst case, it would be no marginal lands at all. So finally, we decided to create something in between, what I would call a half-expert map portal. What does it mean? Within already almost 3 years of our project, we have developed different methodologies to create marginal lands layer, to analyze them, then to create tools for carbon sequestration analysis. And we did it following some research practice. What we presented in the map portal is as a default, you can see our maps, our results, our values which we obtained, and they are always saved as the default option. What user can modify is to change some parameters, but always he can click the button, go back to the default values to see our results. What were the requirements when we were creating the map portal? For sure, it needs to have a map. It needs to have the tool to provide some analysis, or at least show the results of analysis. And it would be nice to have some generator of reports which we can share with the others. And what is not so obvious, we need a portal, a website, which is able to handle a massive storage of data because we are analyzing the whole Europe. In previous presentation, Harry has showed that we have used about 30 different types of layers, different databases with different special resolutions, and we have to combine all of them in one system. Moreover, the special resolution which we decided to follow is the 10 meter by 10 meter pixel, which is actually very high resolution. And all of this led us to search for the optimal solution which will be fluent and which will work without problems on web browser of any users and will not require any type of installation, downloading the software or database, just to minimize the effort which is required for the users. The solution which we decided to choose was Google Earth Engine. And this is the screen of our application, which in detail will be presented tomorrow during the demonstration. What we can do using our portal. First of all, we can identify the marginal lands. As I said, as the default, you can see the map which was obtained as a result of our project. And the second very important part of our map portal is decision support system, which can be used for afforestation or reforestation planning. And this part will be presented in the next presentation by Fernando. I will tell you only about the first part now. So the content, the main content of these parts are products and layers and maps which are available in the software. And in the basic viewer version, we can see actually two products. One is called Marginal Land Productivity. It's the result of analysis showed by Harry, which is the wave sum of all the parameters which we decided to use. And it is scaled to have values from 0 to 100%. What flexibility we gave to the users in this sense? We allowed them, for example, to change our choice. For example, we decided to exclude various land cover and land use classes, but maybe in future user would like to modify it. For example, he would like to include his analysis also some kind of protected areas, so he can also choose it here. What is important, thanks to using Google Earth Engine, all the analyses are done very fast, and just one click is enough to update our map in less than 1 second or a few seconds. The second option which we gave to the users is that he can choose which values of productivity he is interested in. For example, he's interested only in very high productivity pixels, marginal lands, so he can choose it, or maybe he's interested only in the low values. And the third option is the most complex one. It's related with the soft layer, which was described in previous presentation. And here you can see 3 groups of parameters which have specific waves, specific ranks, which result from scientific review. But maybe from some reason, in some specific region, the user wants to change the value, the rank of specific group. So this is the place where he can do it. He can modify all the whole group, the importance of the whole group, or he can modify also the single rank parameters. The second layer, which is visible in the tool, is productivity classes. Here it's also a result of the soft layer classification, where we divided our productivity map into 3 classes. Class with high suitability marginal lands, low suitability marginal lands, and unsuitable areas. What user can change here? He can perform this division into 3 classes in 4 different ways. Was also showed as the examples by Harry. He can use the equal division, 2 types of percentiles, or define the thresholds by himself manually. What is also very important is the area of interest, because theoretically we were working on the whole Europe, but from the user perspective, probably it will be actually performed quite locally. So the area of interest which is done within the project depends on the area which user is looking at, but he can also choose some specific administration divisions which are already predefined and can be selected, and all analysis can be done, for example, only for these regions. What about access to our map portal? Generally, it will be free and open. It requires only one thing, Google Earth Engine account, but actually this account is also for free, so everyone can use it freely. If you would like to know more details about this tool, I invite you for the demonstration on Friday, and there will be also dedicated section about our tools in the mail MOOC, which will be also described tomorrow. Thank you for your attention.
Okay, thank you, Michal. So let's see if we have any question. It seems that we don't have in the chat if someone wants to participate. So one question I have is about the modifying factors, the capability of modifying some factors like sustainability, terrain, or soil in this application or Earth application. So what is the main what are the main purposes of these modifications? So from the point of view of a user, what are the main advantages that this possibility for modifying these parameters may have? Is something geographical, regional, is something focused in the applications, or?
Yeah, it's a very good question. The solution which we proposed is adjusted to work for any area in Europe. So we had to be quite general, and the factors which we proposed are adjusted to work everywhere in Europe, but it's some kind of balance that it should work everywhere. But for the specific region, if you have some additional knowledge about this region, and you know that these factors should be more important for the area of Valencia, for example, then you can modify the factors' importance for your area of interest.
Mm-hmm. Okay, thank you. All right, it seems that there is not more questions, so let's go to the last presentation today before the roundtable, which is Fernando Bezares. He's working in the Center for Services and Promotion of Forest Industry of Castilla y León, region in Spain. And he's an environmental engineer and also specialized in geographic information systems, mainly applied to the forestry sector. He worked before at the United Nations, defining remote sensing-based methodologies for the indicators associated with the sustainability goals. So his presentation is also about the Mail Map Portal. It's a decision support system for marginal lands management. So please, Fernando.
Hello, everyone. Thank you very much for your presentation, Luis. I hope it's you can hear me well.
Yes, perfectly.
Yes. Okay, I'm going to share my screen with you. Okay, is it looking correctly, the presentation?
Yes.
Okay.
Well,
can you see it in the full screen or?
Not the whole screen yet. Okay.
I'm clicking on this, but it doesn't appear to be doing anything. Maybe now or?
No, well, now we have the two, one slide and the next one.
Okay,
so maybe you have to get out.
This other one. No? Is it working?
Yeah, now it works.
Perfect. So Hello, everyone, and I'm going to introduce today the decision support system previously mentioned by Michał in his presentation, basically for managing marginal lands and proposing them as afforestation areas. So first of all, I just want to go quickly through the structure of the tool that has been presented already. So I would like to make two main differences in the mail toolbox. We will have the main tools to identify marginal lands that have been proposed or explained by Michał, where we have first a function that excludes regions by land cover, and in this way we will set our hard layer as we define it, or our mask of marginal lands, and then we will exclude regions by productivity, and they will give some importance factors for later on classify this product into productivity classes, no, in 1, 2, and 3, which later on we can split accordingly into the percentiles that Michał has presented. So the other branch of our tool that we have is the decision support system. And this consists basically in a framework that allows the user to select within these areas the most optimal areas for a reforestation plan. So to do so, basically the user is guided through an area selection process. Then two ways are presented to identify marginal lands, one considering the latter one. And then we generate a distance filter mask in which the user can provide some distances to key areas, and then we will mask out those areas to focus the analysis there. And finally, once we have the tools, the marginal lands selected, we pass this layer into the analysis tools, which I will later on explain. Michał already said this whole structure has been implemented in Google Earth Engine and has the main key is that it's really fast. It runs on the fly, so the user doesn't need to download anything. So the main structure of the toolbox is represented in this workflow. And as you can see here on let's say on the left, we will have the tools presented by Michał, and the right is the decision support system. So the user first is going to select the area defined in two ways, as a NUTS3 or user-defined area. Then we're going to identify the marginal lands according to the what I call the marginal land European classification, or the older classification, which is based on the excluding the regions by land cover, or an enhanced classification, which I will explain later. Once we have identified these marginal lands, the user will select what type of reforestation do they want to carry out. If it's a protective or a productive reforestation, they will have two types of distance filters to apply according to these goals. And finally, when we mask the marginal lands according to these filters, we will pass this thing into the analysis tools, which I introduce now. There are a carbon calculator, a carbon predictor, and a forestation cost calculator. So the first step, as I said, it would be defining the NUT3 areas. For this purpose, the user will select the area of interest, and in this case can be by the NUTS3 areas, which we represent using the global administrative unit layer, level 2, the GAU, and this can look like this. This is an example of the Ardennes in France, or by giving a user-defined polygon if your area doesn't suit to any NUTS3 level. Then, as I said before, the user is given two ways to identify the marginal lands, and one is the European classification, the one that presented Michał, and the enhanced. And what does the enhanced classification do? Well, the enhanced classification is a supervised classification based on Sentinel-1 and Sentinel-2 variables and optical indexes that I'm going to explain right now. First of all, the classification or the classification creates a European-based map training layer, a training layer that is based on Sentinel-1 and Sentinel-2. The Sentinel-1 variables are basically the VV and VH indexes or values computed for the months of April, June, and October. And the Sentinel-2 corresponds to the indexes from the SAVI, NDVI, and NDTI. On top of that, the NDVI, we have computed an harmonic model that we will extract the phase and the amplitude. And all these variables have been combined into a multi-band image, and we have defined it or named it as the European base map for training. So once we have defined this European base map with all the interest variables, what we do is, well, I forgot to mention this. This layer is defined for 2 years, 2017 and 2019. And now, what is the key difference with the previous identification method is that this one can be tailored by region and by date. So the user can specify any date within the Sentinel-2 time interval of occurrence, and then they can run their classification and get a marginal land image. So to do so, the training classes are obtained by using the land cover of Sentinel-2 GLC, developed by CPK, the marginal, non-marginal classification layer, and the hard layer. We get the training classes from this, and we distribute them using a random sampling. From this point, we get our training points, and finally, we combine this then with our European base map. And now, using our dates that have been inputted by the user, now we run the previous variables for Sentinel-2 and Sentinel-1, the VV, VH, and the optical indexes, and then we pass it into the random forest classifier. We get a classified image, which is basically land cover, in which one of these classes is our marginal land class, which we will extract. And then in this way, we'll have our marginal land identification at 10-meter resolution. So once we have the marginal lands identified, then we select our type of reforestation. And we consider that the two types of reforestation that we have can be either protective, if the goal is to make ecological restoration, if you want to perform hydrological restoration, or the driver of the reforestation is not mainly economical. And for this purpose, we have thought about two types of filters. Would be the feasibility filter, which they relate with how difficult it is to carry out the reforestation in an area. So we will be the distance from crops, roads, and urban areas, and finally the biodiversity filters, which is the density, the distance to forest and protected areas that can work as, for instance, connectivity areas or stepping stones between already biodiverse rich areas. And the only key difference with the productive reforestation is that the productive reforestation, we understand it as a type of reforestation or plantation that its main goal is economical. No? And in this sense, we will only consider the feasibility distance filters. For these filters, the user will be able to say if they want their afforestation to be carried out either closer than a certain amount of meters or further than this certain amount of filters. So after this, after the user has selected their distances to each land cover, we will get what we call a distance mask, in which we can see in white where our suitable areas for reforestation, and then this we will use it to mask our classification obtained previously. So in red we can see the suitable areas, the marginal lands that fall in suitable areas for the reforestation can currently indicated by the user previously. So finally, when we have these red areas and we know where we want to carry out our afforestation, it's time to use the analyst tools that will give a sense of how much carbon is already can be planted there, how much can it cost an afforestation there. So we have mainly 3 tools in the panel, and these are the carbon calculator, which is based, it calculates the carbon for a given diameter at breast height for several selection of species using biomass equations. These biomass equations have been described and generated by the team of Forrester et al. At 2017, and they can present some limitations given that they are generalized for the whole Europe. But if you are interested in one specific species, I will suggest you to refer to the documentation. Nonetheless, they have been calibrated for whole Europe and they are functional. The second tool is a carbon predictor, which combines the biomass equations proposed by Forrester and predictor or increment model for diameter at breast height calculated by Shellhas, where these authors they model and they have fitted some equations to predict the increment of carbon, of the DBH in different regions of Europe according to environmental variables and terrain variables. So with these models, we predict how much the diameter is going to increase in a certain pixel, and once we know the distribution of diameters for a range of years, we apply the carbon calculator to extract and calculate the biomass and carbon of each species. And once we have this, we have an non-carbon related calculator, but more an economical calculator that retrieves the cost of planting one tree based on several indicators such as slope, distance from the city, soil texture, and labor cost. So basically, this calculator takes in account data-based price in which we know how much does it cost to plant a certain plant under technical circumstances, either if it's mechanical or manual, and then using a weighted layers such as the slope and the cities and the soil texture, we have distributed the cost and specialized the cost all around Europe. I would like to indicate that right now in the tool in the menu, these analysis tools are already included, but the distance filters are in a beta version. So for tomorrow, the distance filters are not going to be able to be seen, but they are expected to be included soon, as well with a tool that generates carbon sequestration groups. So this indicates that the tool is still alive and is not going to just die here. And finally, I would like to refer you to the technical documentation specifically for the carbon tools. If you have any doubt, you can ask me, or please refer to the documentation. And I would like to end the presentation thanking all the development tool and all the people that has worked on the DDS and the Marginal Lands tool, and thank as well IABG for the coordination, and thank you to Elke Kregmaat and to Jan Aramin for coordinating this task. Thank you for your attention, and please, if you have any question, ask me.
Okay, thank you very much, Fernando, for let us know how this tool has been developed and the different applications. So, by the way, when and where this tool will be available for everybody? The mail map portal.
The mail map portal is already available in an alpha version, which includes the tools that Michal has presented and the analysis tools. So the only feature that is still left is the the selection by filters, by distances. We expect to have this by the second half of December, more or less, before the project is completely over. And also, like these filters and these implementations is in a separate script. It's functional in another script, but we just have to fix one bug and then include it into the tool. So we expect that there is not much. It doesn't take us much time to include it.
Mm-hmm. So it will be available through the website of the project, right? Of the mail project.
Yeah, I think it will be available through the mail website, and also it's a link. That's an application that, as Michal said before, you just click it and then it will shoot you to the application. So I expect it to be in the mail portal and just a link to the application.
Okay, so just some question about that. All right, so it seems that there is no more questions from the participants. So thank you again, Fernando. And